Hey guys, welcome to Unit 8A, Section 5, and we were talking about inscribed angle measures. So inscribed angles, as you can see here, the inscribed angle is on the circle. So it's on the outside, the circumference of the circle. And then the intercepted arc is when the two rays intersect 2 points across from that inscribed angle. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So if this is x, it is half the size of the intercepted arc, so we could say this is 2x. It's better if you know the inscribed angle, because then you can just double the intercepted arc. All right, some theorems that go along with this idea. If two inscribed angles intercept the same arc, then the two inscribed angles are congruent. So notice they both connect here at A to B, so that would make angle D the same as angle C. This next theorem is a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So what we would need to identify here is the fact that this angle D is congruent with angle F, and then angle E has to be congruent with angle G, because those would be the opposite angles. So a follow-up to this would be, can you inscribe and then we have all these different types of quadrilaterals. I'm just going to go ahead and, for the sake of time, tell you which ones work. So a square is a yes. Rectangle is a yes. Those are both yeses because they have right angles. So 90 plus 90 for the opposite angles would be supplementary. And then a trapezoid is a yes if it's that special trapezoid, if it is an isosceles trapezoid. And then the rest are actually going to be no, because a rhombus, if the rhombus is a square, then it would be yes, but assuming it's just a regular rhombus that isn't a square, the opposite angles are not supplementary. Same thing for a kite. And a parallelogram, opposite angles are congruent, but not necessarily parallel. So the first two are yeses and trapezoid if it is an isosceles. And then a couple more theorems that go along with this. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Now the reason this is because if that's 90 degrees, that would make this go 180, forming half of a circle, and also making that a diameter. Because the inscribed arc would be 2 times 90, which would be 180. And then the converse to this idea, if a triangle is inscribed in a circle and one side is the diameter, so assuming that we know A to B is a diameter, then the triangle is a right triangle, because if the inscribed angle is 180 degrees, this angle has to be half of that, making it 90 degrees. All right, we want to calculate the arc measure indicated, and we want to be able to justify our reasoning. So the measure of arc ABC. So that is this whole arc right here. And if this is 90 degrees here, that tells us that this arc would be 180, because this would have to be 2 times that, and leaving the other half of the circle to be 180 degrees. The measure of arc AC, so from here to here, well, we have an inscribed angle of 70 degrees, so that is half the size of the arc, so what we're going to do is take 70 times 2, and give us 140 degrees. This one is a little more complicated just because there's more pieces going on. Determine the angle measure listed. So we want to start with ABE. That's this angle right here. So if this is 90 degrees from here to here, and that's an inscribed angle, it's going to be half that size. So we're going to take 90 divided by 2, and that gives us 45. Then we have ACE, so that's a huge angle, or a huge arc. Oh, we're not talking about an arc, we're talking about the angle. So ACE, that's this angle here, but notice that ends at the same points, A and E. So if this was 90, then half of 90 is still 45. And then the last one, ADE, also shares the same endpoints of AE, so making that is 45 as well. So you can see, even though the angle might look different and it's vertex is located in different spots, since they share these same endpoints of A and E, it makes those angles congruent. Okay, for this one, the measure of angle B is 31 degrees. And it wants to know what the measure of angle C is. Well, again, notice they share the same intercepted arc because they both have endpoints of A and D. So that would make these angles congruent. And then over here on X, so notice SU goes through the center. That's a hint and an indication that SU is a diameter. So that tells us that if that's a diameter, this has to be half of 180, which is 90. So we can set those equal to each other. Divide by 5, and we're going to get X equals 18. So it's a lot of relationships of identifying when you have congruent angles, when you have diameters, recognizing that the inscribed angle is half of the intercepted arc, and vice versa, going back and forth, doubling or dividing by 2.